Motorcycles have always pushed boundaries, testing limits of speed, power, and design that defined what two wheels could achieve. But some features pushed too far. Innovations that seemed brilliant on paper but proved genuinely dangerous on the road. Components that killed riders, and design choices so flawed that manufacturers, regulators, or physics itself forced their removal from production. Today, we're counting down 12 motorcycle features so dangerous they were banned. From suspension systems that caused death wobbles to engines that arrived with turbo lag so severe they terrified riders. From handlebars so tall they violated state laws to exhaust systems so loud they brought regulatory crackdowns. These aren't just bad ideas. These are features that proved dangerous enough that the industry, governments, or simple market rejection eliminated them from motorcycles, creating cautionary tales about what happens when engineering ambition exceeds common sense or when profit motives ignore safety realities. This is the story of motorcycle features that went too far. Number 12. Factory suicide kickstands. The 12th feature that was banned takes us back to older Harley-Davidson and Indian models, equipped with factory suicide kickstands, spring-loaded stands that snapped up automatically when weight was removed, creating genuinely dangerous situations where motorcycles could fall if nudged or bumped. The spring-loaded design seemed convenient, automatically retracting the stand when riders mounted and began moving, eliminating the need to manually retract stands before riding away. The danger came from stands that would snap up without warning if the motorcycle was bumped, nudged by passing vehicles, or disturbed by wind, vibration, or uneven surfaces settling under the bike's weight. The spring tension was substantial enough that once the stand started retracting, nothing could stop it from snapping fully upward, leaving the motorcycle supported only by its own balance or the rider's ability to catch it before it toppled completely over. The scenarios were genuinely hazardous. Riders parking motorcycles on suicide stands and walking away could return to find bikes lying on their sides after bumps or vibrations triggered the stands to retract. The damage ranged from scratched paint and bent levers to cracked engine cases and destroyed bodywork when heavy motorcycles crashed onto pavement with nothing to cushion the impact beyond whatever parts hit first. The safety implications extended beyond property damage to genuine injury risks when riders were standing next to motorcycles that suddenly fell, creating situations where hundreds of pounds of steel and iron could pin legs or crush feet. The unpredictability meant riders couldn't trust that motorcycles would remain upright once parked, creating anxiety and requiring constant vigilance that shouldn't have been necessary with properly designed equipment. Modern regulations outlawed suicide kickstands, mandating positive lock designs that required deliberate action to retract and wouldn't snap up accidentally, regardless of bumps, vibrations, or disturbances. The positive lock stands used mechanical detents, holding them in deployed position until riders physically lifted or kicked them into retracted position, eliminating the dangers that spring-loaded designs created through their automatic operation. Number 11. Excessive factory fairings. The 1988 BMW K1 takes 11th position for radical aerodynamic bodywork that caused dangerous instability in crosswinds, leading to withdrawal after poor safety record, revealed that aggressive styling created more problems than the aerodynamics solved. BMW designed the K1 with full bodywork, covering nearly the entire motorcycle, creating a dramatic appearance that looked futuristic and suggested advanced aerodynamic efficiency. The massive fairings created substantial surface area that caught crosswinds like sails, pushing the motorcycle sideways violently when wind gusts hit from the side, or when passing trucks created sudden pressure changes. The forces were strong enough to require constant steering corrections, maintaining straight-line tracking, creating fatigue and genuine danger when crosswinds were sustained or when multiple trucks were passed, creating repeated pressure changes that pushed the bike unpredictably. Seen a banned motorcycle feature on the road? Know someone who survived riding one of these death traps? Drop your story below. Subscribe now. More banned tech and dangerous engineering coming soon. The aerodynamic problems multiplied at high speeds, where the large fairings caught more air and created stronger forces pushing the motorcycle sideways. The instability became genuinely dangerous during highway riding, where sustained speeds above 80 miles per hour combined with crosswinds to create situations where riders fought constantly to maintain lane position and prevent the wind from pushing them into adjacent traffic. The massive surface area of the bodywork acted like a vertical sail, catching crosswinds with such force that riders had to lean the motorcycle several degrees into the wind just to maintain straight-line tracking, creating exhausting physical effort during extended highway rides. The problem was particularly severe when passing semi-trucks, where the wind shadow on the approach suddenly disappeared as the motorcycle cleared the truck's front, replaced by violent crosswind that pushed the bike sideways several feet in an instant without warning. The steering corrections required to counteract wind forces became so frequent and substantial that riders developed arm fatigue within minutes of sustained highway riding, reducing their ability to make precise inputs and increasing accident risk as concentration waned. The front fairing panels were particularly problematic, extending outward from the motorcycle's center line and creating leverage that amplified the forces trying to rotate the bike around its steering axis when wind hit from the side. The lower fairings that extended down to protect the engine and exhaust also caught wind that lifted the front wheel, reducing steering precision and creating a light, vague feeling at the handlebars that made riders nervous about maintaining control at highway speeds. The turbulence created by the bodywork wasn't just external. Air flowing around the massive fairings created buffeting at the rider's helmet that was violent enough to cause neck fatigue and headaches during rides exceeding 30 minutes at sustained speeds above 70 miles per hour. The weight of the extensive bodywork added approximately 40 pounds to the motorcycle's overall mass, most of it positioned high and far from the center line, raising the center of gravity and making the K1 feel top-heavy during slow-speed maneuvering despite the relatively low center of gravity when bodywork was removed. The mounting points for the fairings proved inadequate for the aerodynamic loads they experienced, with several owners reporting cracked mounting brackets and loose panels after extended highway use, where constant wind pressure stressed the attachment points beyond their design limits. The paint and graphics on the fairings were expensive to repair when damaged, with the complex curves and large surface areas, meaning that even minor scratches or cracks required replacing entire panels rather than spot repairs that simpler bodywork would allow. The visibility was compromised by the massive fairings blocking peripheral vision and creating blind spots that made lane changes dangerous because riders couldn't see vehicles approaching from angles that conventional motorcycles' smaller fairings would leave visible. The maintenance access was terrible, with mechanics needing to remove extensive bodywork to access basic service items like spark plugs, air filters, and valve covers, turning routine maintenance into hours-long projects that dramatically increased ownership costs. The resale values reflected buyer skepticism about the radical styling, with K1 models depreciating faster than conventional BMWs and selling slowly when owners attempted to trade or sell because the pool of buyers willing to accept the aerodynamic compromises was limited. The insurance companies recognized the handling problems, with some insurers charging higher premiums for K1 models or declining to cover them entirely, citing accident statistics showing higher claim rates than conventional motorcycles with less extreme bodywork. The rider community was divided, with some defending the K1's futuristic styling, while others mocked it as an example of form over function, creating debates that continued decades after production ended about whether the radical design was visionary or simply misguided engineering that prioritized appearance over real-world usability and safety. BMW withdrew the K1 after sales, disappointed, and safety concerns emerged about the handling characteristics that excessive bodywork created. The radical styling that looked impressive in photographs proved genuinely problematic on real roads where wind was constant variable that the designers hadn't adequately considered during development, focusing more on appearance than real-world aerodynamic performance. Number 10. Factory speedometer delete. Minimalist cafe racers from the 1960s and 70s took 10th position for being sold without speedometers, leaving riders with no speed awareness and creating genuinely dangerous situations when they couldn't judge velocity accurately. Manufacturers deleted speedometers to reduce weight, lower costs, and create stripped-down aesthetic that cafe racer culture embraced as authentic racing minimalism. The danger was obvious. Riders without speedometers couldn't accurately judge their speed, leading to situations where they traveled significantly faster than they realized or couldn't moderate speed appropriately for conditions, traffic, or legal limits that they had no way to monitor. The lack of speed awareness created hazards for riders and other road users who couldn't predict how fast the motorcycles were actually traveling based on visual observations alone. The safety implications extended to legal concerns, where riders receiving speeding citations couldn't claim ignorance when their motorcycles lacked the basic instrumentation required to monitor speed. The enforcement became complicated when riders argued they had no way to know their speed. But that argument failed when courts ruled that operating vehicles without required safety equipment was itself violation regardless of whether speedometer absence caused the speeding. Regulations worldwide eventually mandated speedometers on all road-legal motorcycles, eliminating the minimalist aesthetic that cafe racers had embraced, but creating genuine safety improvement by ensuring riders could monitor their speed and moderate it appropriately. The laws typically specified minimum requirements for speedometer accuracy, visibility, and range, ensuring that basic instrumentation provided reliable speed information rather than decorative gauges that looked authentic but provided no useful data. Number 9. Excessive factory lighting modifications. Colored headlights featuring blue or red, factory-style lamps on some import motorcycles from the 1970s and 80s take 9th position for confusing drivers and mimicking emergency vehicles, leading to bans under traffic laws worldwide. Manufacturers fitted colored lenses or bulbs, creating distinctive appearance that seemed stylish but created genuine confusion about whether motorcycles were emergency vehicles requiring right-of-way or civilian vehicles operating normally. The blue and red lighting mimicked police motorcycles and emergency vehicles, closely enough that other drivers would pull over or yield right-of-way, assuming the motorcycles were responding to emergencies. The confusion created dangerous situations when drivers made sudden lane changes or stops attempting to clear paths for what they believed were emergency vehicles, creating hazards for the motorcycle riders who had no emergency lights or legitimate reason for the deference they were receiving. The safety implications were serious enough that traffic laws worldwide banned colored lighting that could be confused with emergency vehicle lights, mandating white or yellow headlights and red taillights as the only permissible colors for motorcycle lighting. The regulations typically specified exact color temperatures and brightness levels, ensuring that civilian motorcycles couldn't be mistaken for emergency vehicles, regardless of styling choices or aesthetic preferences. The enforcement included mandatory inspections in many jurisdictions, where motorcycles with illegal colored lighting failed registration renewals and couldn't be legally operated until proper white or yellow headlights were installed and verified by authorized inspectors. The penalties for violations were substantial, with fines ranging from $100 to $500, depending on jurisdiction, and repeat offenders faced escalating fines, points on driving records, and potential license suspension for flagrant violations, showing deliberate disregard for safety regulations. The confiscation of illegal lighting equipment was common during traffic stops, with officers removing colored bulbs or lenses on the spot and issuing citations requiring proof that compliant lighting had been installed before the violation could be cleared from records. The liability implications were severe, with riders involved in accidents while operating motorcycles, with illegal colored lighting facing increased insurance rates, potential denial of claims, and civil lawsuits arguing that illegal equipment contributed to accidents by confusing other drivers about the motorcycle's status. The manufacturers were held accountable for factory-installed colored lighting, with importers required to modify vehicles before sale or face fines and potential bans on importing additional motorcycles until compliance was achieved and verified through government inspection programs. The aftermarket industry adapted by ceasing production of blue and red motorcycle lighting, with retailers refusing to stock items that customers couldn't legally use regardless of demand, from buyers wanting distinctive appearance that regulations explicitly prohibited. The education campaigns emphasized that colored lighting wasn't just illegal, but genuinely dangerous, with public service announcements showing scenarios where drivers yielded to motorcycles they believed were emergency vehicles, creating hazardous situations when the deference proved unwarranted. The international standardization meant that color requirements were consistent across most developed nations, eliminating the excuse that lighting was legal elsewhere and creating uniform standards that protected both riders and other road users, regardless of where motorcycles were originally manufactured or purchased. The technology evolved to include amber turn signals as the only exception to the white front and red rear rule, with regulations carefully defining the amber color range and prohibiting any colors that could be confused with blue or red emergency lighting, regardless of how slight the color shift might appear. The enforcement was strict with citations and mandatory equipment changes required for motorcycles found operating with illegal colored lighting. The laws applied equally to factory equipment and aftermarket modifications, eliminating any defense that lighting was original equipment when regulations clearly specified permissible colors, regardless of how motorcycles were originally configured. Number 8. Radial arm suspension. Experimental factory models from the 1980s and 90s featuring radial arm suspension take 8th position for alternative suspension geometry that caused instability and unpredictable handling, leading to withdrawal after recalls revealed that innovative designs created more problems than conventional suspension. Manufacturers experimented with radial arms, replacing conventional forks or swing arms, claiming improved geometry and better wheel control during suspension movement. The radial designs featured arms extending from pivots positioned differently than conventional suspension, creating geometry that should have provided advantages in maintaining consistent wheel alignment through suspension travel. The engineering seemed sound with computer modeling, suggesting improved performance, but real-world testing revealed unexpected problems that simulations hadn't predicted or that designers had dismissed as manageable. The instability emerged during aggressive riding when suspension compressed and extended rapidly, creating situations where the radial geometry caused wheel alignment changes that conventional suspension avoided through simpler, more predictable geometry. The handling became unpredictable, with the motorcycles feeling stable during moderate riding, but developing sudden oscillations or steering changes during aggressive cornering or braking, when suspension movement was violent and rapid. The recalls came after riders reported handling problems that manufacturers initially dismissed as rider error or improper setup, but eventually acknowledged as fundamental design flaws requiring withdrawal. The radial arm experiments ended with manufacturers returning to conventional fork and swing arm designs that were proven, predictable, and safe, even if they lacked the theoretical advantages that radial geometry promised but couldn't deliver reliably. Number 7. Factory straight pipe exhaust options. Early Harley-Davidson, AMF era, models offering factory straight pipe exhaust options take 7th position for excessive noise and reduced back pressure that harmed performance, while creating sound levels that brought regulatory crackdowns. The straight pipes eliminated mufflers and baffles, creating exhaust systems that were essentially open tubes, allowing combustion gases to exit directly without any sound deadening or flow management. The noise was genuinely excessive, with sound levels exceeding 100 decibels at idle and climbing dramatically under acceleration when exhaust pulses created ear-splitting racket that could be heard for miles. The volume wasn't just annoying, it was genuinely harmful to hearing for riders and bystanders exposed to the sound without protection, creating health hazards that regulations eventually addressed through strict noise limits. The performance effects were counterintuitive, with straight pipes actually reducing power compared to properly designed exhaust systems that used back pressure and tuned lengths to optimize scavenging and cylinder filling. The lack of back pressure meant exhaust gases exited too quickly, creating negative pressure that pulled fresh mixture out of cylinders before combustion and reducing power output, despite the intuitive assumption that less restriction meant more power. The dyno testing revealed measurable losses of 10 to 15 horsepower at mid-range RPM, where engines spent most of their time during normal riding, creating weaker acceleration and reduced pulling power that riders noticed immediately, despite the louder exhaust, suggesting more performance. The torque curve was particularly affected with the loss of back pressure, eliminating the low-end and mid-range torque that made Harley-Davidson V-twins enjoyable to ride, replacing the strong pulling power with peaky, high RPM output that arrived too late to be useful during normal street riding. The fuel economy suffered dramatically with the poor scavenging and cylinder filling, creating incomplete combustion that wasted fuel and produced black smoke from unburned hydrocarbons exiting the exhaust, reducing miles per gallon by 20 to 30% compared to properly designed exhaust systems. The engine longevity was compromised by the straight pipes running hotter due to the lack of heat dissipation that mufflers provided, creating higher cylinder temperatures that accelerated wear on pistons, rings, and valves, while increasing the risk of detonation that could damage engines catastrophically. The carburetor jetting became critical, with straight pipes requiring rejetting to compensate for the changed exhaust characteristics. But most riders never performed the necessary tuning, leaving their motorcycles running dangerously lean and risking engine damage from excessive heat and detonation. The backfire on deceleration was constant and violent, with the straight pipes allowing unburned fuel in the exhaust to ignite explosively, creating loud pops and bangs that startled other drivers and created genuine fire hazards when flames shot from the exhaust pipes during throttle closings. The header pipes turned blue from excessive heat within weeks of installation, indicating that exhaust temperatures were far higher than properly designed systems would create, and providing visual evidence that straight pipes were harmful rather than beneficial to engine performance and longevity. The sound quality was harsh and unpleasant, with the straight pipes producing raspy, tinny noise that lacked the deep, rich tone that properly designed exhausts created through careful tuning of pipe lengths and muffler designs optimized for pleasing sound characteristics. The resale value suffered with knowledgeable buyers avoiding motorcycles equipped with straight pipes, recognizing that the loud exhausts indicated either ignorance about performance or deliberate disregard for regulations, both of which suggested the motorcycles might have been poorly maintained or abused during ownership. The regulatory response was swift, with noise ordinances banning excessively loud exhausts and emissions regulations requiring catalytic converters and mufflers that straight pipes couldn't accommodate. The laws typically specified maximum sound levels measured at specific distances in RPM, creating objective standards that straight pipes violated regardless of aesthetic preferences or claims about performance benefits that didn't actually exist in real-world testing. Number 6. Helmet-mounted factory accessories. Built-in mounts for cameras or accessories on certain factory helmet models take 6th position for increasing risk of neck injury and crashes, leading to bans in Australia and parts of Europe after testing revealed that protruding mounts created dangerous force concentrations during impacts. The mounts seemed convenient for action cameras and communication devices, allowing riders to capture footage or communicate without aftermarket solutions. The danger came from crash dynamics, where any protrusion on a helmet could catch on pavement or objects during impacts, creating rotational forces that dramatically increased neck injury risk compared to smooth helmets that slid across surfaces without catching. The mounts acted as levers, multiplying forces applied to the neck, creating loads that could cause fractures or spinal cord damage that smooth helmets would avoid through their ability to slide without catching. The testing was comprehensive, with crash test data showing measurably increased injury risk from even small protrusions, leading to regulations banning any factory-fitted mounts or accessories that extended beyond the helmet's smooth profile. The standards specified maximum protrusion distances and required that any mounts be designed to break away cleanly during impacts rather than catching and creating dangerous forces. The bans were controversial, with riders arguing that convenience and functionality justified minimal risks, but regulators prioritized safety over convenience, and manufacturers complied by eliminating factory mounts and warning against aftermarket accessories that violated regulations. The message was clear: helmet safety couldn't be compromised for convenience, when crash data proved that even small protrusions measurably increased injury severity. Number 5. Unfaired high-speed superbikes. The Kawasaki Ninja ZX-11 from the 1990s takes 5th position for top speeds exceeding 175 miles per hour, with minimal aerodynamics creating dangerous instability at extreme speeds, ultimately leading to the 1999 Gentleman's Agreement, capping motorcycle speeds at 186 miles per hour. The ZX-11 and competitors prioritized straight-line speed over aerodynamic stability, creating motorcycles that could reach genuinely extreme velocities but became unstable when speeds climbed beyond what the minimal fairings and basic aerodynamics could safely manage. The instability manifested as front-end lightness at extreme speeds, where aerodynamic lift reduced tire contact and made steering vague and frightening. The motorcycles felt stable at moderate speeds, but developed increasing instability as velocities climbed toward maximum, creating situations where riders needed constant steering corrections, preventing the bikes from wandering or oscillating violently. The danger became obvious when riders attempting top-speed runs reported genuinely terrifying experiences where motorcycles felt like they wanted to swap ends or tank slapper into uncontrollable oscillations. The speeds were simply too high for the aerodynamics, chassis stiffness, and tire technology available in the 90s, creating genuine safety hazards that manufacturers eventually acknowledged through the Gentleman's Agreement limiting top speeds. The tire manufacturers warned that their products weren't designed or rated for sustained speeds exceeding 170 miles per hour, with the centrifugal forces at extreme velocities causing tread distortion and heat buildup that could lead to catastrophic failures where tires literally disintegrated at speed without warning. The frame flex became apparent at maximum velocity, where the aluminum or steel structures twisted under aerodynamic loads and gyroscopic forces from the wheels spinning at extreme RPM, creating oscillations that fed back through the chassis and became self-reinforcing wobbles that riders couldn't dampen through steering inputs alone. The braking systems were marginal at best for slowing from extreme speeds, with the calipers, rotors, and pads designed for reasonable velocities, experiencing such extreme heat and stress at sustained high speeds that fade became inevitable, and stopping distances increased to lengths that made emergency stops essentially impossible. The psychological factor was equally concerning, with riders reporting that speeds above 160 miles per hour created sensory overload where the landscape blurred. Reaction times became inadequate for responding to road conditions, changing at rates exceeding 250 feet per second, and the mental stress of maintaining concentration at deadly velocities became unbearable after mere seconds of sustained maximum speed operation. The agreement wasn't legally binding, but manufacturers honored it, electronically limiting top speeds to 186 miles per hour and ending the speed wars that had pushed performance beyond what could be safely managed on public roads. The limit acknowledged that unrestricted speed races had pushed too far, creating motorcycles whose performance exceeded what riders could safely use or what roads and traffic conditions could accommodate without creating deadly hazards. Number 4. Two-stroke Widowmaker engines. The Kawasaki H2 Mach 4 from 1972 takes fourth position for 750 cubic inch two-stroke triple, delivering brutal acceleration with chassis and brakes so inadequate. The bike earned the nickname Widowmaker, and eventually stricter emissions and safety regulations ended large two-stroke street bikes entirely. The two-stroke design produced approximately 74 horsepower, with power delivery so violent it overwhelmed the frame, suspension, and brakes that Kawasaki had fitted. The power came on suddenly rather than progressively, with all the output arriving. When revs climbed into the narrow power band where expansion chambers created resonance, supercharging the cylinders. The transition from minimal power to maximum output was so abrupt that riders couldn't modulate it smoothly, creating wheelies and wheel spin that were loss of control rather than controlled acceleration. The chassis couldn't handle the power, with the frame flexing under the violent forces and the suspension bouncing rather than controlling motion. The brakes were genuinely terrible, with a single front disc providing stopping power completely inadequate for the bike's weight and the speeds the engine enabled, creating situations where riders couldn't slow safely from the velocities they could achieve frighteningly quickly. The emissions regulations eventually banned large two-strokes from street use as environmental concerns, and oil crisis pressures made inefficient, polluting engines politically unacceptable. The safety record of bikes like the Mach 4 provided additional justification for regulations that manufacturers didn't seriously resist, because the market had moved toward four strokes offering better efficiency, cleaner emissions, and more controllable power delivery that didn't require riders to manage violent, unpredictable characteristics that two strokes created. Number 3. Excessively tall ape hanger handlebars. Factory customs from the 1970s and 80s, featuring ape hanger handlebars extending above shoulder height, take third position for reducing control and creating rider fatigue severe enough that height limits were enforced in many U.S. states. The tall handlebars created distinctive chopper aesthetic that manufacturers marketed as authentic custom styling, but the ergonomic problems were severe enough to create genuine safety hazards. The control issues were immediate, with riders' arms extended upward rather than positioned naturally, reducing leverage and making it difficult to apply the force needed for emergency maneuvers or aggressive riding. The high hand position meant pushing or pulling the bars required using shoulders and back rather than arms, creating delays in steering inputs and reducing the precision needed for safe riding in traffic or emergency situations. The fatigue was equally problematic, with blood draining from upraised arms during extended riding, creating numbness and weakness that worsened the control problems and made even moderate rides genuinely uncomfortable. The unnatural position created shoulder and neck pain that accumulated during rides, reducing concentration and increasing accident risk as riders became fatigued and less able to maintain attention needed for safe operation. The regulations varied by state, with some limiting handlebar height to shoulder level, while others specified maximum heights above the seat or grips, creating patchwork of laws that custom builders had to navigate. The enforcement was typically complaint-driven rather than proactive, but citations were issued and motorcycles could be impounded if they violated state laws, regardless of whether handlebars were factory equipment or aftermarket modifications. Number 2. Turbocharged engines. Factory turbocharged motorcycles from the early 1980s, including the Honda CX500 Turbo, Suzuki XN85, and Yamaha Seca Turbo, take second position for severe turbo lag and unpredictable power delivery that created genuinely dangerous situations, leading manufacturers to abandon turbos after safety concerns overwhelmed any performance benefits. The turbos were fitted to mid-size engines, attempting to create superbike performance from moderate displacement. But the technology available in the early 80s couldn't solve the fundamental problems that turbocharging created. The lag was substantial, with riders experiencing minimal power until boost built, then suddenly violent acceleration when the turbo spooled and unleashed full output. The transition was so dramatic that the motorcycles felt like two completely different machines, depending on whether boost was active, creating unpredictability that was genuinely dangerous during cornering, when sudden power arrival could overwhelm traction and send bikes into slides. The power delivery varied based on conditions riders couldn't always predict, with boost arrival depending on throttle position, RPM, and load factors, creating situations where identical throttle inputs produced wildly different results. The inconsistency made smooth riding nearly impossible, and aggressive riding genuinely hazardous, because riders couldn't develop muscle memory or instincts about how much power throttle applications would actually produce. The manufacturers abandoned turbos after disappointing sales and safety concerns revealed that riders didn't want unpredictable power delivery regardless of peak output numbers that looked impressive on specification sheets. The market spoke clearly. Smooth, predictable, naturally aspirated engines were safer and more enjoyable than turbocharged power that arrived violently and unpredictably, creating dangers that outweighed any performance advantages that turbocharging theoretically provided. Number 1. Rotary rear damper. The Suzuki TL1000S from 1997 takes the top position as the most dangerous motorcycle feature ever banned, featuring rotary-style rear suspension damper that caused catastrophic instability and wobbling at high speeds, leading to recalls and replacement with conventional suspension after the innovative design proved genuinely deadly. Suzuki designed the rotary damper as lightweight alternative to conventional piston dampers, using rotating disc rather than moving piston to control suspension motion and create damping forces. The rotary design seemed brilliant with computer modeling, suggesting weight savings and consistent damping through suspension travel. But real-world performance revealed fundamental flaws that testing hadn't predicted or that engineers had dismissed as manageable through tuning. The damping was inconsistent with the rotary mechanism, providing different resistance depending on suspension speed and position, creating situations where damping changed unpredictably during riding. The instability emerged during aggressive riding, when suspension compressed and extended rapidly, creating oscillations that the inconsistent damping couldn't control effectively. The rear would begin bouncing or oscillating with the movements building rather than being dampened, creating genuine tank slappers that terrified riders and could become violent enough to throw riders from motorcycles or cause complete loss of control. The danger was so severe that Suzuki recalled TL1000S motorcycles and offered conventional rear shocks, replacing the problematic rotary dampers, acknowledging that the innovative design had failed catastrophically and created genuine safety hazards that couldn't be solved through adjustment or tuning. The recall was expensive and embarrassing, but Suzuki had no choice when riders were crashing, and the rotary dampers were clearly responsible for instability that conventional suspension didn't create. The rotary damper became infamous as the motorcycle feature that even sophisticated engineering and extensive testing couldn't make work safely, creating cautionary tale about innovation that sounds brilliant but proves genuinely dangerous when exposed to real-world conditions that simulations and controlled testing can't fully replicate. The TL1000S is remembered not for its powerful V-twin or lightweight chassis, but for the dangerous rear suspension that made it genuinely treacherous and forced Suzuki to admit defeat and return to conventional technology that was proven, predictable, and safe. These 12 banned motorcycle features prove that innovation without adequate testing styling without considering consequences, and performance without proper control systems create genuinely dangerous machines that regulations, recalls, or simple market rejection eventually eliminate. From rotary dampers causing death wobbles to turbos creating unpredictable power, from ape hangers reducing control to two-strokes earning the Widowmaker name. These were the features that proved too dangerous to continue. Which banned feature shocked you most? Share your thoughts in the comments. Subscribe. More motorcycle history and engineering deep dives coming soon.